In this video, I would like to talk about finding vertical and horizontal asymptotes of rational functions using algebra. So we'll remember that a rational function can be written in this form. It's a polynomial over another polynomial. There's a numerator and a denominator. If we look at these polynomials and they have no common factors, the vertical asymptotes occur where the denominator equals 0. That's the same thing as finding the x values that are undefined for the function. Those will be the same as vertical asymptotes. The only caveat to this is that if there is a common factor of x minus c that would factor out of both the numerator and denominator, that does not result in a vertical asymptote. That simply results in a hole in the graph at that value x equals c. If we are sketching the graph of a function like this, we will simply see a hole, a point missing from that graph. But there is not a vertical asymptote there. Horizontal asymptotes are a bit more complicated. For these, we look at the degree of each polynomial, the numerator and the denominator. And there would be three cases here. The first case is that the degree of the numerator is greater than the degree of the denominator. That corresponds to there being no horizontal asymptote for that rational function. The second case is that the degree of the numerator equals the degree of the denominator. Then we look at the leading coefficients of numerator and denominator, and that ratio forms our horizontal asymptote. The third case is that the degree of the numerator is less than the degree of the denominator. And in that case, there's a horizontal asymptote at y equals 0. So let's apply all that information with a couple of examples. I want to find the vertical and horizontal asymptotes and identify any holes of the graphs of the following functions. We should look at each function in its factored form to begin with. So I'll take the first function and rewrite it in terms of its linear factors. It's 2x minus 3 over x plus 5 times x plus 2. There are no common factors between the numerator and denominator, so there are no holes in this graph. We don't have to worry about that. For the vertical asymptotes, we look at the values where the denominator equals 0. So we say x plus 5, x plus 2 equals 0. What x values would result in this being true? X equals negative 5 and x equals negative 2. The domain of the function is undefined at this point, and the graph, you will see the y values going from to positive or negative infinity as we approach these two x values. What's the horizontal asymptote? Well, let's look at the degree of the numerator and denominator of this function. Remember, for the degree, we're looking at the highest power of the variable for a single variable polynomial. So this is degree 1, I just have x to the first, and the denominator has degree 2, I have an x squared. That is our third case above. The degree of the numerator is less than the degree of the denominator. So what is our horizontal asymptote? It is y equals 0. I'm going to say degree of numerator is less, and so that means the horizontal asymptote is at y equals 0. Let's consider another example. 2x squared plus 3x minus 5 over x squared minus 2x plus 1. Once again, we want to make sure that we factor each of these into linear factors if possible. Our first polynomial factors as 2x plus 5, x minus 1. Our denominator factors as x minus 1 times x minus 1, or you could say x minus 1 squared. Now here, there is a common factor, right, of x minus 1. So we would say there is a hole at x equals 1. That's because of this common factor that we observed, x minus 1. And as we go forward, we will imagine factoring out that common factor and think of our function in this simplified form, just remembering that there is a whole at x equals 1. So what is the vertical asymptote? Well, that is where the denominator equals 0. So x minus 1 equals 0 means the vertical asymptote is at x equals 1. What is the horizontal asymptote? Let's consider the degree of the graph. And we could look at either the original function or the simplified function here. It will result in the same answer. The degree of the numerator and the denominator is the same in this case. This is degree 1, and this is also degree 1. And in that case, we use the ratio of the leading coefficients as our horizontal asymptote. So this is 2x, and this is 1x in the denominator. So the horizontal asymptote is y equals 2 over 1. Those are the leading coefficients of numerator and denominator. And of course, you could say that is simplified best as y equals 2. This is our horizontal asymptote. So we can take information like this and use it to sketch the graph of a rational function.